3. How many of you think that this statement is correct? With a show of hands. What's your gut feeling? How many of you think that this is correct? 1, 2, 3, 4, 4. Okay, so 4 of you think that that statement is correct. How many of you looked at that video that I did with epsilon hats versus epsilons? Did you look at that video that was epsilon versus, because I was trying to compare these two measures, right? These two are very different animals, okay? Now, what you know for sure it's true is that the sum of epsilon I hat is equal to 0. This is purely mechanical property. Do you know what the epsilons are? The actual epsilon? Do you observe them? No, you don't observe them. What makes you so confident they should add up to 0? What feature makes you so confident that they should add up to 0? Let me give you a counterexample. Imagine that this is the true line. So beta 0 plus beta 1. Note I'm not putting any hats because these are true lines, okay? Where will the data points be? Well, the data points will depend on the error term. So for example, it could be that my first data point is here. What does that mean? That this distance, this vertical distance here, is epsilon 1 without the hat. My second data point could be here, okay? This means epsilon 2. My third data point could be here. This means epsilon 3, for example. Could I have gotten something like this? Is there something that prevents that data to be there? Nothing prevents the data to be there. So if you're trying to fit an OLS on just these 3 data points, of course OLS would mechanically fit a line such that the residuals now, this would be the residual, epsilon 1 hat, epsilon 2 hat, epsilon 3 hat. The OLS line, that's the OLS line here if you like, OLS line, this thing here is the true unobserved line or relationship if you like, okay? So the OLS residuals, the sum of them have to mechanically equal to 0. The sum of the epsilons from that graph, you should immediately see it doesn't have to be equal to 0 at all. You have no clue what those things are. But here's one very important relationship with the 0. What do you know about the expectation of epsilon I? 0. What you're saying is that the expectation of this random variable, which is called the epsilon, which is unobserved and I don't know of, is equal to 0. So what can you say about the expectation of sum of epsilon i's? What would that be equal to? The sum of the expectations? But what is each expectation? 0. So this thing here is going to be equal to 0. So this statement here is not true. Okay? This statement here is also not true. However, I could have modified this statement. I could have, of course, asked you a question in an exam that might have looked like this. Sum of epsilon I hat is equal to the expected value of epsilon I is equal to 0. Is this correct? In that case, that would have been correct. Okay? So on average, those epsilons, those unobserved epsilons should be centered around 0. But there's nothing that prevents them to be all positive on one sample, okay? Especially if the sample is relatively small. Or to be all negative in another sample, especially if the sample is relatively small. Right? Now, of course, if I go back to this graph, and if I went a little bit crazy with the data points, and I had a lot of data points, right? And I had a lot of them, then perhaps it would be easy to see that in expectation those epsilons should be 0. But not that any given sum will be equal to 0. Okay? In expectation that should be equal to 0. Is everybody with me? Okay. Now, of course, there's another very subtle thing which I don't want to confuse you with, but as n approaches infinity, right? As the sample size is very, very large, what do you expect the sum of epsilon i's to be?
Closest possible to 0.
Well, the expectation is exactly 0. It doesn't matter what the n is. But the actual sum will also be fairly close to 0, as the sample n is very, very large, right? Because the probability that you're going to get all positives once you have 1,000 data points is pretty much 0. Okay? So the distribution of that sum is going to have lower and lower variance over time. But we can never say what's going to be the actual. Yeah, Charlie.
So the sum of the error term is not, sorry, it's not 0 because we have a sample. It's not the whole population.
Correct. Yeah. So the question that she's asking is that the sum of this is not 0 because we have a sample, not a population. Let's try to specify that these are really population parameter, right? These are things that we don't observe, but these are the epsilons that are relevant to the particular sample that I've collected. Okay? So if my sample in this case had 3 data points, I'm just going to be adding 3 epsilons. But I don't know what those epsilons are. Those are unobserved, okay? By assumption, and this is an assumption, right? When I say this is equal to 0, this is not always the case. It's just we assume that to be. This is an assumption. Okay, so that's sort of like my discussion for question 3.